Thank you, everyone, for attending session 1B of RDAP Summit 2024. So excited for this session. This is a Zoom webinar. Attendees are muted and your cameras are turned off. So to ask a question, please use the Q&A at the bottom of the screen. And this session will run from 1:15 to 2:15 p.m. Eastern Daylight Time, with the last 15 minutes or so for question and answer. This session will include 2 live presentations followed by 2 pre-recorded lightning talks. You will be able to ask questions of presenters from both live and recorded talks at the end of the session. Please indicate the presenter or presenters you would like to direct your question to, and we'll save all questions till the end of the session. After the session, please feel free to drop questions and continue the conversation in the session chat in FeedLoop. And I also found a cool way to be able to expand that chat so that it covers more of the screen by clicking on the sort of square looking icons on the top right of the chat. And we are committed as RDAP Summit organizers to provide an environment where all attendees can participate fully in the program and activities without fear of harassment or discriminatory behavior of any kind. There is a code of conduct helper available during this session. That'll be Emily Kilser. They're identified as a CLC helper in FeedLoop as well as in Zoom, and you may direct messages to them in FeedLoop if you need assistance. They can give you the code of conduct email address or link to the incident report form if needed. So without further ado, I'm very happy to welcome Anna Bazaha and Kelsey Badger from The Ohio State University to kick off today's session with their presentation, Into the Unknown, Seeking Perspectives from Non-Users. Take it away.
Hello, and thank you. Welcome to our presentation. In this presentation, we will be discussing a research project we are currently undertaking to explore the thoughts and preferences of researchers regarding university research data services. My name is Anna Bazaha, and I'm a research and education librarian at The Ohio State University Health Sciences Library. And I'm presenting today with my colleague, Kelsey Badger, who is the research data librarian for the Ohio State University Libraries. So to get started, we'll provide you with some background information about how our project came about. So our study is part of a larger multi-institutional coordinated project being conducted by Ithaca SNR. This overarching project involves 2 cohorts with a combined total of 29 universities investigating data support services available across different campuses and how to better communicate and streamline those services. The Ithaca SNR project has multiple phases over 2 years. We began by conducting an inventory of data services on campus last spring, followed by the researcher interviews we will be discussing today. And coming up in year 2, we'll be working with our campus partners to translate these research findings into action. So the methodology, what did we do? The interview project consisted of 16 qualitative semi-structured interviews with researchers on our campus, specifically faculty, staff, and grad students, but excluding undergraduate students, over the fall of 2023. The interview script was broken into 3 main sections. The first set of questions asked researchers about their current data practices, such as what their typical data management process looked like. The second set then related to their research data training and support needs with questions like where they go to learn new data skills, as well as whether they have ever used campus services to support their data needs. And the last set of questions then looked to the future and what they thought they might need down the road, including whether they thought different data management and sharing mandates may impact their future data support needs. It's important to note that within the context of this project, we were using a specific definition for the phrase research data services to mean, quote, programmatic offerings such as trainings, workshops, and consulting that support data-intensive research. And this was the definition provided to us by Ithaca and was given to researchers in the preamble and introduction of the interview to help them think about what they may have used and keep the conversation in context. In terms of how this project related to the larger Ithaca SNR project, Ithaca provided institutions with the interview script, as well as rough draft materials for the protocol and communications, and we will be sharing our de-identified transcripts with them to be synthesized with the other institutions. Individual institutions were then asked to select specific population on which to focus their interviews, such as, postdocs or specific disciplinary areas. And we also refined the materials they provided to our local circumstances. So in our training, they suggested using personal connections and networks to identify and recruit participants. However, we decided to go in a slightly different direction. Many data service providers will focus their own quality improvement or assessment work on their existing users. And we were aware of at least a few local initiatives by different groups to get input from their users. We didn't want to duplicate those efforts and hear much of the same information. And after some discussion with our campus partners, we determined that the group we most wanted to talk to were the people we didn't know, with the hope of catching at least some non-users of data services. Though this group is more challenging to recruit, we thought that the benefits of targeting people outside our known networks might be worth the effort, and it would allow us to kind of head into the unknown and hopefully get a glimpse of what we otherwise don't know. If we were successful in connecting with an otherwise untapped or unfamiliar population, we may get a better sense of those needs that are currently unmet. And we also hope that this approach may help mitigate any concerns of preconceived notions that current users may have, such as limiting their discussion of services they know exist, as opposed to thinking more broadly about what they need. So to recruit this population, we gained access to a university dashboard of funding awarded to university employees. And then from this dashboard, we then extracted a list of grant-funded projects from the previous 12 months. From this pool, we then wrote an R script to randomly generate a list of 24 grant-funded projects that were stratified into 4 funding buckets with 6 representatives coming from each. We grouped the research projects in this way with the hopes that it would help ensure a breadth of research was captured. However, we do not intend to intentionally look for differences between these groups. We then reviewed the list for completeness, such as missing PI information, as well as inclusion criteria like whether or not the project was actually a research project as opposed to something else like service provision. We also attempted to minimize overrepresentation of any particular discipline and replaced entries as needed. We then sent out direct invitations and reminder emails to the PIs listed on the identified projects, and this recruitment process was repeated 4 times, reaching a total of 96 researchers. Of note, we reviewed the lists for disciplinary overrepresentation for the invite portion, but we did not control for this in the acceptances. So this graph gives a sense of what our recruitment looked like from a disciplinary perspective. Of note, these were the affiliations of where the identified grants were administered, which we discovered was sometimes different from the affiliation of the researcher themselves. You will also see that though we did invite them, researchers from some colleges simply didn't respond or declined to participate. So from our experience, we were able to pull out some things that we thought were successful in this approach, as well as some of the challenges we encountered. As we will describe in our initial findings, we felt like we got a good mix of disciplines. With a campus as large and varied as Ohio State, we could not hope to get a truly representative sample of all disciplines possible, but we did not feel like there was too much overrepresentation from any groups. We were also fairly successful at reaching at least some non-users. Only 4 of the 16 participants, so 25%, described previously using a library data service. Additionally, many participants did not report any clear use of a campus data service. Kelsey will talk about this more in the following slides, but there was a fuzziness around what is a data service that has made it challenging to easily classify users and non-users. One issue we encountered was the fact that we were working with messier data than we expected. For example, we had set the date parameters to be within the past 12 months to reach current researchers, but we ended up retrieving some older grants because their records had been edited recently. And it was also difficult to discern at times if something was truly research or if it was something like service provision. The rate of non-response to our invitations was higher than we originally anticipated, which meant we had to keep recruitment open for longer. And another challenge we encountered was discovering that the words we were using in our communications impacted our ability to recruit participants. We found that some invitees did not view themselves as performing data-intensive research and would self-select out of the study, even though we suspected they would be able to provide insight. Additionally, even within the interviews themselves, some participants did not self-identify as using or working with data or data services, even though they clearly did. Lastly, since we were recruiting from grant-funded research and contacting the PIs, we inadvertently acquired a focus on later career researchers. This meant that some people we talked with described themselves as somewhat removed from the day-to-day research activities. And we had anticipated this, and our invitations included language that allowed the PIs to refer us to another researcher in their lab. but we expected to get referrals from a senior researcher to perhaps a more junior faculty member, postdoc, or grad student. However, we ended up receiving more lateral referrals to colleagues, which then retained the later career focus.
Thanks, Anna, and hi, everyone. I'm going to transition now to a few slides on our findings. Just a little bit of a disclaimer, we're just now finalizing transcription and de-identification of the interviews, so these are more like initial impressions and not yet a formal analysis. So to start off with, as Anna mentioned, we conducted a total of 16 interviews, depicted here in terms of discipline and rank. Also, as Anna mentioned, a disproportionate number of our participants were later career researchers. So 50% of those represented on this slide are tenured faculty members, including 5 full professors. However, we did also speak to 4 research staff, 3 assistant professors, and 1 postdoc. As Anna mentioned, given the small sample size, we were pretty happy with the mix of disciplines that we had. The participants represented here conduct research with a wide array of data types, so including microscopy, remote sensing, sequencing, interviews, field observation, and administrative records, just to name a few. We did review our recruitment list for disciplinary overrepresentation before sending out invites. Although we weren't aiming for a truly representative disciplinary sample, we wanted to keep disciplines like medicine and engineering from overtaking the list. As a point of reference, as far as that goal goes, the grants dashboard that we sampled from was about 40% medicine. So that's a slightly larger percentage than what we ultimately interviewed in that area. So before jumping into what we heard in the interviews, I want to say a little bit more about the definition of a data service that Anna mentioned earlier. To ensure consistency across the universities in Ithaca study, it was important to have a common understanding of what is and isn't a data service. The same definition was used both in the inventory of data services in the first phase of the project, as well as in these researcher interviews. And basically, it has 2 parts: the type of service and its mode or focus. For type, on this left-hand side of the slide, we were focused on either one-to-one consultation or group training like workshops and seminars. And then for mode, over on the right-hand side of the slide, we were considering both general topics like data management, statistics, and visualization, as well as more specialized areas like geospatial data, bioinformatics, and digital humanities. So I'm spending all of this time reviewing the definition because one of the major things we encountered was that there were considerable challenges communicating this definition to our interview subjects. Even if they didn't express any concerns with the definition during our preamble, we found that many struggled to differentiate between our narrow definition of a data service and other types of university research support that they were familiar with. So this slide shows a preliminary grouping of some of the things that researchers discussed that we wouldn't have categorized as a data service. The first category, which we're calling data resources, still clearly relate to data, but are more concerned with infrastructure. So examples in this category include resources for computationally intensive work, data storage, shared instrumentation like imaging cores, and contract services for acquisition or analysis. The second category we're calling research process, and these are things that don't even clearly relate to data, much less to a data service. In the words of one of our participants, these are not data problems, these are science problems. And examples in this area include the needs and challenges of scientific training, resources obtained through personal connections, and experiences with other offices in the research support enterprise, like sponsored programs or IRB. All that being said, most of our participants did share some feedback that met our criteria for a data service, and this slide focuses in on those things. Some of what we heard was affirming, including one participant explicitly stating that we need more data librarians. However, we were particularly interested in identifying challenges, so things that could help reveal opportunities for us to improve. These could be services that aren't being offered yet, like on the left-hand side of this slide, or barriers to engagement for existing services on the right-hand side of the slide. So one clearly expressed need that we heard is more support for the challenges of working with bigger and bigger data. Some of these are already pressing concerns, like help with computational training or storing and archiving big data. and other issues are more emergent. So, for example, several participants stated they were worried that their current processes for managing data were fine right now, but that they probably wouldn't scale very well as data volumes continue to increase. And many researchers were also concerned about the increasing role that AI technologies might play in research and how they'll develop the necessary skills. Another need participants discussed was for workshop training that went broader and deeper than our current offerings. This took many forms, including requests for more training specific to university resources, for version control like Git, and training that is appropriate to intermediate learners. And then switching over to the right hand of the slide, participants identified a wide variety of barriers to service engagement, which we've summarized into kind of 3 groups. So first, the belief that a service probably doesn't exist, usually based on the perception that the issue is too specialized for university support. Second, there's what we might call activation barriers. So researchers know that the service probably exists, but they don't have the time or the resources to seek it out. And lastly, we did hear some accounts of researchers who have had previous bad experiences and are hesitant to try again. So to close, we want to share a few final thoughts that bring things back to the conference theme of interoperability. The motivation for this study was to improve how data services are communicated to researchers and coordinated across campus partners. As we reflect on the next steps for this goal, a few big ideas have emerged. First, we have a major messaging issue. Although we were working with a definition of data services prescribed by Ithaca, it really does closely adhere to the way that our programs are actually advertised. And meanwhile, most of the researchers that we spoke with felt that their data needs couldn't be readily extracted from the rest of their research support needs and didn't adhere very well to this definition we were using. Many also felt uncomfortable with the epithet data intensive, and those who did identify with it had a pretty narrow perception of what it meant, such as associating it only with like large-scale secondary data use. Second, we need to clearly identify what is and isn't in scope for research support units like the library and our campus partners. As the research landscape continues to evolve, it seems likely that some of the needs identified by our participants should actually be addressed by changes to graduate curricula. There was a clear message that they would like us to go deeper with our workshop training, but some of these asks may be too discipline specific to expect out of a university-wide service. And finally, it's also worth noting that the more specialized the services become, the more demanding they are to develop and maintain. Campus coordination can extend staff capacity, but it's still a finite resource. Going forward, we hope to reach new users with our services, but without losing sight of how staff capacity impacts scalability and sustainability. And with that, we'll turn it over to the next presentation, but thanks so much for your attention.
Thank you so much, Anna and Kelsey. What a great presentation and a great project that you put together. I'm really looking forward to the final results that you pulled together. So our next presentation is going to be from Zi Ni from RTI International, presenting on understanding how to identify and manage personal identifying information, PII, to further data interoperability. Take it away.
Sure, just give me 1 second. I'm just going to be sharing my screen. Mode.
Looks great. Well,
Okay.
Once you put it in presenter mode, yep, looks great.
All right. Sorry, everyone. I'm actually still fighting off a little bit of a cold. But good afternoon. Today I'm going to be talking about essentially PII. And the reason that I wanted to create this presentation and to present it at this forum here, RDAP, is through some of my recent work, I'm interacting with a lot of different researchers as part of various initiatives, both within academia and within industry. I have found that there are some misunderstandings about what constitutes PII that I'm hoping that through this presentation that we can clear up and that we can provide a framework for guidance on how to understand how to identify PII within your data. So to start off with, I'm going to start off with going over some of the legal definitions of PII. These are going to be wordy, but they are important for establishing a foundation. Then I'll move on to, through some of the discussions that I've had why there appears to be some confusion and misunderstanding about what constitutes PII. I'll then move on to a framework for helping to determine what is and is not PII within your data. And then moving on, I'll finally conclude, summarizing everything in this presentation. So a lot of text on this slide, but this is, again, with legal definitions, there's a lot of things that a lot of details that have to be talked about. So what you're looking at here is guidance for what is personal identifying information, PII, from the Department of Labor. The important parts of here are like, PII is essentially information that allows you to identify an individual within the data set. They give a few definitions about, PII that can be things that directly identify an individual, such as things like names, address, social security number, those kind of things, or by which an agency intends to identify specific individuals in conjunction with other data elements. And of course, these data elements may include things like gender, race, birthday, geographic indicator, and other descriptors. And of course, there is an additional clause here about information permitting the physical or online contacting of a specific individual is the same as PII. Typically speaking, though, within the research settings, this doesn't really come up. What we're really looking at from this definition here is like, the PIIs that define as things that directly identify or things that can indirectly identify an individual within your data. Another very important definition that comes up a lot, particularly within medical health research, is PHI, or protected health information. This is a specific type of information that's defined under HIPAA, the Health Insurance Portability and Accessibility Act, which defines it as individual identifiable health information held or maintained by a covered entity or its business associates are acting for the covered entity. That part is actually very crucial and something that's kind of misunderstood in that, the HIPAA privacy rule for a lot of health research data actually does not apply because it's not data that is generated, maintained by a covered entity for the purposes of providing healthcare services. Most health research data, the researchers themselves may be, it may be that this data is generated through under working for a covered entity like a hospital or insurance provider or things like that. But a lot of the times when you're doing healthcare research, your data actually is not necessarily PHI simply because it is not data that is generated by a covered entity. Now, that was a bit of a side, but moving on. So the important part of determining what is or is not PHI is the next paragraph, which talks about identifiable demographic or other information relating to the past, present, or future physical or mental health condition of an individual, things like that. So with these two definitions, what happens and with a lot of people who just read these definitions is that it makes it seem like what's important, what is the actual identifiable information are like different columns within your data. Like say if your data has names or social security numbers, it's the name column or the social security number column that is the PII or the PHI. But that's not really true. So if we use this framework of thinking, for instance, there is actually quite a lot of uncertainty around the methods of indirect identification, as mentioned within the Department of Labor's guidance. So that definition states this is information by which an agency intends to identify specific individuals in conjunction with other data elements. And they may include things like age, sex, zip code, race, birthday, geographic indicators, and other descriptors. Does that mean that things like age and sex and zip code are in fact PII and PHI? Maybe, yes and no. It could be that these fields in the context of the data you have are actually PII, but that heavily depends on whether you can actually use those fields to, in conjunction with other data elements as part of the definition to identify a data subject. So let's take a look at this example, for instance. We have this full list here. We have, all these names as such. And let's, instead of thinking about it as about this kind of like what is PI versus what is PHI in terms of columns, we can take a look at this record, for instance, and say, okay, what can we actually use within this record itself to identify this individual? Well, I mean, for starters, we have immediately their name and their social security number. Those are direct identifiers, and with those fields, you pretty much can just say, okay, this person is in fact Jane Doe with social security number that, and you can pull up all kinds of records about them just by searching that information. But what if we actually remove their name and their social security number? This information that is left, can you still use it to re-identify the data subject? Maybe. If you can, then it's not so much, for instance, that if you can actually use this to identify that this is Jane Doe with that social security number, then it's not that the columns of like age, sex, and zip code for everybody are PHI. It's that this record in and of itself is just is still personally identifiable information, because the contents of the record are what allows you to identify it. So basically, even if you, like in this case, even if you remove the name and the social security number, if this is enough to identify a data subject, then this entire record in and of itself is PII. It's not the columns that are the PII, it's this entire record, everything that's contained within it. So with that in mind, let's talk a little bit about different frameworks for how you actually identify whether you have PII in your data. We have within the United States a highly prescriptive, rules-based, legally defined framework under HIPAA Safe Harbor, where you can where it calls for removal of 18 different types of identifiers, which are listed on screen, as well as no actual knowledge within the residual information that can identify the individual. That part's a little bit extra. I won't get into it too much, but essentially, there is this framework which lists out 18 specific types of identifiers, where if you remove this information from all the records within your data, then you actually have de-identified data, and legally speaking, this data should not be able to identify a data subject. But again, this is under HIPAA. This only applies to medical records generated by covered entities. So for a lot of research data, which falls under the common rule, for instance, this framework may not in fact be very appropriate, which leads to the second framework, which is based on expert determination. And this framework relies on a method called classification, which allows you to go through the fields within your data and determine what fields could be identifying within a record. So, what the idea behind classification is that it's to help you identify the potential fields within a record that could lead to identification or re-identification of a person within your data. This does not mean that these fields are what's PII. Again, what is PII is the record, not the fields. But it's a method of looking at the different fields that you have to determine, okay, these are the kinds of things that we need to look out for. And let's actually, go through a quick example using the classification framework. Same kind of fields as before, same kind of from the example as before. What we would do is we would go through essentially this decision tree, and we'll take each field and go, okay, is this field replicable? Which means, does this field remain more or less consistent over time? Is this field distinguishable? Does it allow you to tell a difference between different records within your data? Is this field knowable? Is this something that if I was to try to re-identify someone within your data, I can use this information to try and re-identify them? That's really what is the key to determining, the kind of records that you want to look out for. Then if, the field satisfies these three conditions, then we would look at, is it able to identify an individual solely based upon its contents and no other variables? So if we take name, for instance, name is replicable, distinguishable, knowable, and it is able to, and you are able to identify individuals solely based on the contents of the name because it tells you who that person, what the name of that person is, then what we would classify it is as a direct identifier. Something like age, for instance, still replicable because it remains constant for a person over a year. It's distinguishable because it allows you to distinguish between people of different ages within your data. And it's knowable because if it's someone who, an acquaintance of yours, you know what their age is. Plus, it's something that you can find within the public record. You can buy voting records from different states for like $20, and it'll tell you people's like ages and their sexes and which zip code they live in and things like that. So that's publicly available information, and so definitely know. But age is not, you aren't able to identify an individual based solely upon their age, because there's many people who are aged like 32, for instance. So that would actually be moved, okay, to know, is it useful for analytics? Probably, you probably want to know how old someone is, in which case this field would be what is known as an indirect identifier or a quasi-identifier. And what we would do is we would go through each one of these fields essentially and go through this process. Okay, is sex replicable, distinguishable, knowable? Yes. Can you identify it by solely based on its contents? No. Can it be used for analytics? Probably yes. So probably as a quasi identifier. Of course, there are certain fields where you won't put it as that. Like for instance, hours worked this month. Could it be replicable and distinguishable? Probably. Is it knowable? For someone who doesn't work with the person, probably not. In which case, we would go down home and we could probably put it as a non-identifier. Same thing with date of record creation. Again, replicable, distinguishable, probably, but the knowability aspect here is really key. It's like, who would know when this record was created? So it would probably fall into a non-identifier field. And of course, we would go through each one of these fields and classify each one of them based on this kind of framework, So after performing this classification, though, the key to determining, whether a record is in fact PII or is not PII is to perform a risk measurement. And this risk measurement essentially measures the likelihood, probability, or the risk that a person can be identified or re-identified based on the contents of these fields. So in a situation where you have direct identifiers present, like the name or the social security number, the likelihood, because we ought to be, take conservative estimates, we will set that likelihood directly to 1. Because again, even though there may be thousands of Jane Does, the fact that you have the name of Jane Doe means that you have the identity of the person. So, that would be set as 1. And of course, the social security number is right out. It is like, the important identifier that is consistently used and is relatively unique. So basically, having direct identifiers within your data would set the likelihood that you would re-identify someone to 1 because you've identified them. Now, if we remove the direct identifiers of name and social security number, though, how will we actually determine the risk? So what you do is you have all these different quasi-identifiers, and you would take the quasi-identifiers themselves and conduct a statistical measurement to determine the likelihood that this person can be re-identified. There's a bunch of different methodologies that you can use to do this. The simplest and most well-known of these is k-anonymity, which basically takes groups within your data and aggregates them together to see like how many people are age 32, female, live in this zip code, are a nurse, have this salary, and work this many hours. But of course, that is the simplest methodology, and there's many, many more. This risk measurement in and of itself should be performed by an expert with sufficient knowledge and experience with generally accepted statistical and scientific principles. Applying such principles to perform the risk measurement, this is basically the definition of an expert determination under HIPAA. These experts I understand that these experts are hard to find, and that there are not very many of them, and there is a standard for a framework for conducting these kinds of evaluations, but there's many, many different ways of doing it. So when you're doing such a thing, definitely make sure that you have a good expert on your side to do this for you, and that they are able to really explain this methodology and provide documentation of what it is that they're able to do. So some concluding thoughts. First things first, and the first thing I want to make clear is that PII is not about fields within your data. It's about the record itself. What makes a record identifiable are the fields that it contains, the values of those fields, and that we really should be changing our thinking from like the very various variables, the vertical columns within your data, to looking at horizontal rows, the records within your data. To determine what could be identifying within your records, you should perform classification. And after performing classification, to determine which ones of your records are actually PII, you can perform a risk measurement to determine whether they can be re-identified or not. So provably re-identifiable records are still PII, even if you have applied the identification. Just want to leave everybody with that. So thank you, everyone. I hope you all learned something, and I'm happy to stay on and share it and answer any questions if needed.
Thank you so much, C. I learned so much from that talk. I really appreciated the flowchart that you had for determining whether the field is identifiable or not. I thought that was really cool, and I'm definitely going to be thinking about that, using that in the future. So with that, we are going to turn to our two lightning talks next. So they're going to be played back to back, and we're going to be starting with the I in FAIR, Developing a Variable Standards Finder for Researchers, presented by Heather Barnes and Sabrina McCutcheon from RTI International. And then that will be followed by Finding FAIR in the Government Information Ecosystem, presented by Deborah Yoon Caldwell, James Jacobs, Linda Kellum, and Sherry Laster from the Preservation of Electronic Government Information Project, or PEGI for short. Take it away.
Hi, everyone. My name is Heather Barnes, and I'm here with my colleague, Sabrina McCutcheon. We are from RTI, and we are presenting today on a topic we call the I in FAIR, which is about our efforts to build a variable standards finder in support of interoperability in the NIH HEAL data ecosystem. Just for a bit of a background about the HEAL data ecosystem, the NIH HEAL initiative's ecosystem goal is to accelerate HEAL-generated data and results sharing among the broad communities of researchers, healthcare providers, community leaders, policymakers, and other stakeholders who can benefit from learning about and discovery of research results. So the problem that we aimed to address in building this tool is that non-standardized data in biomedical research can inhibit interoperability, the I in FAIR. We know that researchers' knowledge of data standards tends to vary widely. We've encountered lots of questions from researchers that we work with about what metadata, how it's defined, what are data standards. Investigators wonder where to find information about data standards and making decisions about which standard is the right one for their data. So the solution that we have been developing is a variable standards finder. It's based on a list of 8 questions that investigators can answer that link them up with options, data standards that they can explore. It returns a short list of 1 to 3 standards that are either recommended or required. And the tool is interactive and it helps folks explore and learn about new standards.
Some of those questions that Heather just mentioned are about things like which part of NIH funded this award, what's the type of research you're doing, what's the study subject type, or what is the data type. And we ask these questions, including this first question, do you have an award in mind or not, so that the tool can be used either prospectively or retrospectively. So someone could use this tool if they are putting together a proposal for a HEAL-funded award that's not yet gone out yet, and they want to find some standards they can write into their data management and sharing plan. Here are some examples of the standards that the tool might return, including the HEAL library of common data elements that's specific to the initiative. And really the standards we chose to include are either common data elements or their standardized vocabularies and ontologies that have been really well vetted and are well supported in their communities of practice. This is a sneak peek of what the tool itself looks like. There's some explanatory instructions on top, and then there's questions along the left-hand side, along with standards tiles on the right-hand side. As somebody progressively clicks through those 8 questions, tiles change color depending on whether a recommended resource for a standard or a required standards resource has been identified. So in this example, we've identified based on answers to questions that this person is required to use those HEAL common data elements. And they're also recommended to take a look at CDASH and some other NIH authored common data elements as well. In order to be successful, the tool needs to do 4 things. First, it needs to have a really specific purpose. The tool only does the one job. It returns very narrow answers. We don't want to overwhelm people with a lot of options they have to sort through, so they get a minimum 1, maximum of 3 responses. The tool has to enable collaboration. People need to be able to share results of their recommendations with the rest of the team. And it all needs to be very user-friendly. We envision people doing this on a mobile device whenever they have a spare 30 seconds at the airport or something of that nature. Some of the challenges in developing the tool are that it does have a really narrow scope. This tool has to be used in complement with other resources to actually help people get across the finish line for implementing standards. It relies on self-reporting, so the recommendations are only as good as the inputs. It has a fairly complex selection logic for how it picks a standard to recommend. And finally, it just needs to be tested. We welcome any feedback or questions you have for us. You can reach either Heather or myself, or feel free to reach out to the HEAL data ecosystem and the stewards team at any time. Thanks.
Thanks, everyone.
Hi, welcome to our session, Finding FAIR in the Government Information Ecosystem. We are really excited to be here at RDAP Summit 2024. My name is Linda Kellum. I'm at the University of Pennsylvania Libraries, and we are a group called PEGI, PEGI Project. We imagine a world in which government information is preserved and accessible for an engaged and equitable democracy. And our goal is to help build capacity for libraries to preserve foreign digital government information. A question that we've been exploring and thinking about is the application of the FAIR principles as a framework to understand the government information ecosystem and how that may or may not meet public needs for current and future use. I'm going to hand it over to James to talk more about this.
Thanks, Linda. I'm James Jacobs at Stanford University Libraries. So at PEGI, we explore federal information dissemination practices because the US government could have a significant influence on the application of FAIR principles as one of the largest publishers of information and research data in the world. To our minds, all born digital and digitally reformatted government information is itself data. FAIR principles are increasingly part of the practices that federal agencies take into consideration for improving public access to federally supported and federally produced research data. Some of these practices have been developed following the guidance of the Office of Science and Technology Policy, or OSTP, and the Office of Management and Budget, or OMB. However, government information extends beyond research data. The vast majority of federal government information produced for public access is not published in a repository, but directly to agency websites, and may or may not be curated for long-term access. So let's quickly explore the federal information environment with an eye toward the FAIR principles. And I'll hand it off to my colleague, Sherry.
Hi, everyone. My name is Sherry Laster. I'm at Arizona State University. And the example we're going to take a look at today is the Artemis plan, which is the recently released plan from NASA for their upcoming lunar exploration missions. And the Artemis plan is available on the NASA website. If we go to the next slide, please, we'll see that this plan has also been captured and described in a catalog. This is the catalog of Government Publications, which is operated by the U.S. Government Publishing Office, which is a federal agency. So in the setting of this catalog, we can do a quick assessment as to how fair this may be. So we can see that in terms of findability, there is some rich metadata here that includes some controlled subject headings. There's system numbers that can be used to access the metadata, but it's designed to work within this catalog. And there are pearls that are used as persistent links to the digital objects, but they are not serving as a persistent identifier. Next slide, please. In terms of accessibility, it is available through standard internet protocols. This metadata can be retrieved using Z3950 protocol, but there isn't a public open endpoint such as an API that can be used to retrieve this metadata. These records are available through GitHub, but that is not continually updated as the catalog is updated. Next slide, please. In terms of interoperability, GPO is using current metadata standards for the cataloging practices, and the records can be added to other library catalogs, but the machine readability of this metadata is mixed. Next slide, please. In terms of reusability, the metadata is focused on the content of the digital object rather than the technical aspects of that object. And it's missing information that might be needed for reusability, such as the copyright status. Next slide. So in conclusion, will we say this is fair? Certainly it is closer to meeting fair standards than it is when it's sitting on a website, but you can see from this brief overview that there might be some more distance to go. So handing now to my colleague, Deborah.
Hey, so I'm Deborah Ian Caldwell, she, her. I'm the Data Services Librarian at the University of North Texas. Next. So the CGP is just one example from the expansive federal information landscape. And here we have some examples for each FAIR criterion that can illustrate the variety of information practices across federal agencies. And with so much variety, it's really challenging to characterize current GovInfo dissemination practices with respect to whether or not they are fair. There's some really interesting mixed results and opportunities for improvement. And again, we go into more detail about this on our blog post, which you can find linked on the landing page of our website, peggyproject.org. Next. So yeah, in conclusion, the FAIR principles have been really, really important for assuring that research data is funded by the U.S. government and that the research data that is funded by it is curated and made available. However, the federal government information landscape is expansive, and research data is only one segment of this space. And we see a lot of possibility for aligned interest here. So what questions does this raise for you? We would really love to know. Please chat with us in the following Q&A, and or feel free to email us or check us out on our website. Thank you.
Thank you so much to our Lightning Talk presenters, Heather, Sabrina, Deborah, James, Linda, and Sherry. I'd invite all presenters for the session to now join me on screen as we answer some questions. All right. Thank you so much. And thank you to Sherry for answering that last question in the Q&A there. And that brings us to the top of our hour and the end of our session. Thank you to our wonderful presenters and our audience for participating in this session. And we'll see you at our next session in about at 45 minutes past the hour after our 30-minute break. During the break, I would encourage you to check out our sponsors in the exhibit hall tab of FeedLoop, and the posters are already available in the 2 poster sessions, so go check those out as well. And session 2B will be in the same Zoom webinar for the next session, and you're welcome to stay connected during the break, and please check the FeedLoop schedule for the link to session 2A. Thank you so much, everyone, and have a great rest of your summit.